factoring is a step on the way to solving. The eventual goal is to solve binomials and trinomials. One of the best methods for solving, it's not going to be the only method, but one of the best methods for solving is factoring. If you have a binomial, are we all clear about why that would be called a binomial? Has two parts. The first thing you look for in all of your factoring is a GCF. Is there a number that divides 3 and 18? Do they both have a variable, the same variable? So I can also factor out an x. So this 3x comes out in front. 3 divides 3. This x divides one of those x's. 3 will go into 18 how many times? The first thing you always look for is a GCF. Is this a binomial? Does it have a GCF? No. Then the second thing you look for, if it has a GCF, you factor out the GCF. The second thing you look for is the difference of two squares. First of all, are there two terms? Is there a negative sign? Are these numbers variables perfect squares? X squared, the square root of x squared is just x, and the square root of 100 is 10. They're perfect squares. If you have the difference of two squares, it factors into this plus minus pattern. By the way, it doesn't have to be plus minus. It could be the other way around. If I multiplied that out with a box problem, when I combine like terms, the tens would cancel, and so that's what it would be equal to. Question? No, you'll have to go back and catch up. This is as slow as I can do and get through what I need to this class period. Okay, first question. Does it have a GCF? No. No GCF. Is it a difference of two squares? Well, is there a difference? No. Are they perfect squares? No. Then this does not factor. It is prime. There are only two ways to factor a binomial, either a GCF or a difference of two squares. Is there a GCF? No, no GCF. Is this the difference of two squares? 4 is a perfect square, 25 is a perfect square, but is there a difference? No. So this is, I wrote the word prime like you knew. Let me remind you, prime means the only thing that factors into it, or the only thing you can divide out of it, is 1 and itself. And so there's no other factors. If you have a binomial, there are two ways to factor it, a GCF or a difference of two squares. Now we are going to move to trinomials. Okay. For trinomials, if the a is equal to 1, what do I mean? A is equal to 1. A trinomial in standard form looks like this. Is it in standard form? What's equal? A is the square, b, and the c is, so the a is 1, b is negative 8, and the c is 15. There is a process for a equal to 1. Multiply the a times the c together. That would be 1 times 15. What are the factors of 15? Now, when I do this problem, I do it in a very organized manner, and I always start with the smallest factors. The factors of 15 are 1 times 15. I always put the 1 times the number because that's the one people forget about. And then 3 times 5. Are there any other factors of 15? Now, just FYI, some of you are not very good at your factors. You're not very good at your multiplication facts. So, now, on the Schoology page, not in any folder, there's a chart with all the, not all the factors, but the most that we use. The number 7 is not on here because 7 is prime, and the only factors of 7 are 1 and 7. 11's not on here because it's prime. The only factors of 11 are 1 and 11. So if you have difficulty with your factors, that chart is available to you. Okay, so what I am trying to find is some factors that are going to add up to negative 8. If this is positive, they have to have the same sign. If this is negative, they have to have negative signs. So would these multiply together for a positive 15? Negative times negative makes a positive. But if I add them up, can I get a negative 8? Are there any pairs that are going to add up to give me a negative 8? Those are going to make my factors. You do not have to do this on every problem, but just to show you what I'm doing is I am doing the box problem backwards. You do know what I'm doing here when I'm doing a box problem? X times x is x squared minus 3x minus 5x plus 15. Combine like terms. Is that the problem we started with? And so by doing this little chart, I'm breaking it back down into the box problem. Chloe, what was your question? Speak up. When you add negative 3x plus a negative 5x, that's equal to negative 8x. You're talking about here when you combine like terms. When you add, let's go ahead and put that in your notes, x plus another x is 2x. X times another x, that's where you get x squared. You get x squared from multiplying an x times another x, because that's the actual meaning of what the exponent means, that you've multiplied them together. When you are combining like terms, you are adding them together. Good question. That was so fun, we better practice again. n squared minus n minus 12. It is in standard form. What is the A? What is the B? What is the C? You with me on that? I am going to multiply the A times the C together, and I'm going to get a negative 12. I'm going to come back to the signs in a minute. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. If this is negative, 1 in the pair has to be negative. Not both of them, just one of them, because positive times a negative makes negative. If this is negative, the bigger one has to be negative. If the B is negative, the bigger one has to be negative. If this is negative, one of them has to be negative. Now, is there any pair that could add up and equal a negative 1? If I added those together, would that equal negative 1? And so that now, I started with a square, and here I don't have a square. So that's what I'm trying to do, is get rid of the square, and that's going to help me solve it when I get to the next step. So, just to show you, to check, combine like terms. This is the check. We're not going to do it in every problem, but I'm doing it in the first couple of problems to help you get the process. 4x squared minus 8x minus 320. Before I do the A's and the B's and the C's, I always start with a GCF first. Is there a GCF? This GCF is going to factor out in front x squared minus 2x minus 80. And the A is going to be 1, and the B is going to be negative 2, and the C is going to be negative 80. I'm looking at the factored numbers for my A's and my B's and my C's. Okay. Multiply the A times the C, and you get a negative 80. Now, that's kind of a big number, but you're going to see it's going to break down pretty fast. And so the factors would be 1 and 80. It's even, so 2 is going to go into it. 2 and 40. Do you know the shortcut to tell how if 3 will go into it? If you add the numbers together, what's 8 plus 0? It's 8. Does 3 go into 8? No. So up here on the 12, what's 1 plus 2? 3 going to 3. And so if you add the digits together and 3 goes into it, then 3 goes into the big number also. Y'all know that little number trick? So 3 doesn't go into it, but 4 does. It ends in 0, so 5 goes into it. How many times? 16. 7's not going to go into it. 8's going to go into it. There may be some more, but I think that's enough. So, If B is negative, then my bigger number is negative. If this is negative, only one of them is negative. Do we see a pair now that could possibly add up to the -2? The 4 still stays out in front. And so we have a +8 and a -10. By the way, it doesn't matter if you, oh, that would matter because I was about to change the signs. We are not solving for anything yet, but that's going to be coming next. This is one step on the process. What we are going to be doing next is then taking each one of those and breaking them down further. But I mean, this is enough to do it once. It is, so we teach it a step at a time because it would just be too much if we tried to do it all at once. And so this one is a one that tricks people a lot. Does it have a GCF? The first thing is always GCF. No GCF, so the A is 1, the B is 5, and the C is -6. So if you multiply 1 times 6, and so we have 1 times 6 and 2 times 3. So a lot of people stop right there. 2 times 3 adds up to 5. That's the wrong pair. Because if this is negative, something down here has got to be negative in order to get a -6. But this is positive. So that means the bigger number is positive. That means the signs have to go in like that. So it's not 2 and 3. That's not the pair I need. What pair do I need? It doesn't matter which way you write the answer, whether the +6 is first or the x minus 1 is first. But what does matter is that the 1 has to be negative and the 6 has to have the positive sign. Now, I don't remember if I did it on today's assignment, but I have another kind of problem to cover. In order to make it easier to type in, because that starts getting difficult to type in with the parentheses, that's the correct way to write the answer. But in order to make it easier to type into Schoology, I ask the first factor and the second factor. And so you would type in the x plus 6 and the x minus 1 without the parentheses. I did it that way. It's not as mathematically accurate, but it's easier to type. So to help you on the typing so you didn't have to do all the parentheses, I asked for you to type in the factors separately without the parentheses. Question? And so there is another kind of problem that was problem number, were we on 8, 9? So, not that one. 9x squared minus 12x plus 4. Does it have a GCF? Well, 3 goes into those, but does 3 go into that? No. And so what is the A? What's the B? And what's the C? Have I yet taught you what to do if the A is not 1? The process that I was just giving you in the example only applies if the A is equal to 1. Or you can factor out the GCF like we did in this problem, factor out, and now the A is equal to 1. But I can't factor anything. Learn a whole special process when the A is not equal to 1, but this is a special kind of problem. This is called not the difference of two squares, but just a perfect square problem. Because the square root of 9 is 3, and the square root of 4 is 2. And what's A times C? 6. And what's 6 times 2? 12. This applies if A is a perfect square, if C is a perfect square, and if B is 2 times the square root of A times the square root of C. It's not as complicated as it looks. Okay. I told you, it's not as complicated as it looks. Are these perfect squares? And so this will factor into 3x times 3x. Is that going to, when I multiply those together, would that give me the 9x squared? And this is going to factor into negative 2 times negative 2. If I multiply negative 2 times negative 2, is it going to give me the 4? It's negative because this sign is negative. Well, is that going to give me the 12 in the middle? Let's check it out and see. Nine x squared minus 6x minus 6x plus 4. Does that give me the negative 12x in the middle? That's what this means. If these two multiplied together and then plus 2 are equal to that one, then this is a perfect square trinomial. Don't get terribly hung up on this. If you don't quite get this one, that's okay. I'm going to teach you another way. There is a pattern to this one. First of all, does it have a GCF? But is 25 perfect? Is 9 perfect? Is B equal to 2 times 5 times 3? Then it is a perfect square trinomial. This is going to be 5x times 5x. That's how you get the 25. This is going to be 3 times 3. That's how you get the 9. And whatever that sign is, if that's negative, these will be negative. If that's positive, then everything will be positive. I feel the doubt in some of your minds. So we'll check it to make sure. You can always check with a box problem. Do you feel pretty confident about doing a box problem? 5 times 3, negative 15x, negative 15x plus 9. 15 plus 15 is the minus 30x. Like I said, if you didn't get those last two problems, that's okay, because we will be talking more about how you can find the answer if you don't see the pattern there.